This is section 16.2, and we're going to talk about volumes. And so we've got a couple of formulas that we need to learn. So the idea of the volume is a solid of revolutions. So if you take an area and you rotate it around an axis, so if we have this curve and we were talking about the area underneath it between A and B, and think about if you just took that and swung it around the axis, it would create a solid. And so the radius as it goes around is f of x, okay? And so the formula for the volume, you've got your integral from a to b, but you've got f of x squared. That's different than just area. And then we multiply it by pi outside the integral. So think about the area of a circle, pi r squared. Well, remember, this is our radius, so it's kind of like that. All right, so the other formula is the average value of a function on an interval from a to b. And the only thing different, we take the integral from a to b of f of x dx, so it's just a regular integral, but on the outside of the integral, we're doing the average. So we're doing 1 divided by b minus a. So it's just a calculation. So let's go look at our problems and see what we've got. So the questions are printed here, but there's not really much room for me to work. So we'll look at the question, then we'll go down and look at the work. So the first one just says, find the volume of the solid generated by revolving the region around, and it gives you this information. So let's go down here. We have y equals 4x, which is this line, and we're talking about it from x is 0 to x is 3. So we just have this region in here. So we're going to rotate that around. So we have volume is equal to pi on the outside from 0 to 3 of 4x, and remember we square it. Now I have done this one by hand. You could use your Math 9 for this part and then add pi, multiply your pi on the outside. But let's go through this. So this is 16x squared. You can pull the 16 out. So you have 16 pi on the outside. You're integrating x squared. That becomes x cubed over 3 from 0 to 3. Your 0 is going to cancel out, so we have a 0 there. But you plug in the 3, you get 27 over 3, which is 9. And so 9 times 16 is 144, and that becomes 144 pi. You could do it on Math 9. All right, let's look at number 2. Let's go back here. Volume of the solid of a revolution, you get y equals square root of x from 0 to 18. So let's go down here. So from 0 to 18 and square root of x. So same idea, pi, 0 to 18, square root of x squared. Well, when you square that, you just get x. And so you've got pi, and then you're going to integrate that. That's x squared over 2. Evaluated from 0 to 18. When you plug in 18 squared and divide by 2, you get 162. The 0 cancels out. So you've got 162 pi. All right, that's number 2. Number 3. I keep forgetting to go back up here. So we've got 2x squared, y is equal to 0, x is 3, x is 4. So we've got v equals pi, integral from 3 to 4 of, now it's the area between this and y equals 0. So it's this shaded piece in here. So we have 2x squared squared. And so that's 4x to the 4th. When you integrate that, you can pull out the 4. You're integrating x to the 4th, which becomes x to the 5th over 5. We are plugging in both the 4 and the 3. And so that is done here. Those numbers, and then multiply by 4, end up with 3124 over 5 pi. If you do that with Math 9, you do need to convert that fraction back. Okay. Number 4. The function defined by the square root of r squared minus x squared has as its graph a semicircle with radius r and center at 0, 0. Find the volume that results when the semicircle of y equals the square root of 25 minus x squared is rotated about the axis. So let's go down. I think I want to show you this one on the calculator. It's got a good bit of work, but we're going to do it on the calculator. So here's our function, and we know it's from -5 to 5. So your integral would be v equals pi times the integral from -5 to 5, and then this function squared. All right, so I'm going to grab the calculator and bring it up. I already put it in so that we wouldn't take up too much time with that. So Math 9, put in the -5 and the 5. The thing I wanted to show you, this parenthesis is for the box. That's what you'll get when you just go inside the box. But we want to put this function inside a set of parentheses because we're going to square it. Otherwise, we'll lose some stuff. So be sure that you have double parentheses in there, and then come out and put your x. You get 166.66. So it's 166 2/3, and you end up being 500 over 3 is what that is. And so your answer is 500 over 3 pi. Let's look at number 5. All right, so those are all volumes. Then we have 2 questions that are about the average value of the function. So remember, we have to switch gears a little bit. This is find the average value of this function on this interval. So let's go down here to number 5. All right, so f of x equals, there's our information again. So remember that, so the formula says you do 1 over b minus a from 0 to 2, so from a to b, x squared minus 2 dx. So you're integrating, same way, x cubed over 3 minus 2x, and out here you've got a 1/2. So you do all that. You could do it with Math 9, obviously, and you could get this value here. So if you're doing it with Math 9, you're just going to have a 1/2 that you'll multiply at the end, but you could do this part in your Math 9, and you should still get -2/3. This one, same idea, square root of x plus 1 from 0 to 3, so that's 1 over 3 minus 0 from 0 to 3. This is to the 1/2 power because that's what a radical is. I would use 0.5 if you're putting it in Math 9. And you should ultimately get 14 over 9 when you multiply the 1/3 there. The last question is a application problem. And so it says a stock analyst plots the price per share of a certain kind of common stock as a function of time. So how's your stock going to do over time? Finds that it can be approximated by the function s of t equals 24 plus 16e to the -0.08t, where t is the time in years since the stock was purchased. Find the average price of the stock over the first 6 years. So that just tells you you're going to go from 0 to 6, and it's still average price of the stock. That's that last formula we were just using. So here's the formula. So we got 1 over 6 minus 0. Integral from 0 to 6, put your function in there, and it's dt. Now, if you use Math 9, I've shown you what it looks like. 0 to 6, 24 plus 16e to the -0.08x dx. You get 220.24, some stuff here. You have to remember on the outside you had 1 over 6 minus 0, so you're going to divide by 6. And then we're talking about money. We're talking about the average price. So we're converting this to money. We would round then to 2 places. We'll have $36 $1.71. So one application problem and 6 of the others should get you through 16.2.